Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on GeeksForGeeks for 6th April 2023. The problem statement for today is equal left and right subarray sum. This problem is based on arrays and prefix sum, and this has been asked in companies like Amazon, Adobe. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Given an array A of n positive numbers, the task is to find the first index in the array such that the sum of elements before it is equal to the sum of element after it. Okay, so we have to find. So we will be given with one array, and we have to find such an index so that all the elements to the left and to the right of that index has the equal sum. Okay, so that's why the problem statement is saying equal left and right subarray sum. Okay, so let's go through and understand the given examples here. So here the first example says the size of array is 5 and array contains these elements 1, 3, 5, 2, 2. So the output is 3, because for second test case at position 3 element, before it 1 plus 3 and elements, and after it is 2 plus 2. So both if you look at both the sum, 1 plus 3 is equal to 4 and 2 plus 2 is equal to 4. That's why the position of the element is 3. Actually, we have to note one thing: the array is one based index. So if you look at this with array's perspective, so it will be at index position 2. But since it is array 1 based, so that's why we are returning 3 here. So that means first element will be at index 1 like this. So if you look at this example, then this 5, then sum of all the elements left of it and right of it is equal. That's why the output is that. In the second example, here it is given n is equal to 1 and array contains only one element. So here the output is 1. Since there is only one element, hence is the only point. I hope this is clear. So the approach or the algorithm that works for this is first computing the total sum of all the elements in the array. Then it iterates over the array and keeps track of the sum of element on the left side of the current index. At each index, it checks if the sum of the elements on the left side is equal to the sum of elements on the right side, which we will be computing using the formula of total sum minus sum of elements on the left side minus the current element. If such a point is found, we return the current index. If the loop completes without finding any such point, then we return -1. Okay, so this approach we will be following for solving this question. So let's understand it in a better way with one example. So I've taken the same example here, 1, 3, 5, 2, 2 here. So if you see the total sum of it is 13, and initially before the loop starts, so we are initializing left sum is equal to 0, and within each iteration, within each loop, we will first check if the left sum is equal to the right sum. If that is equal, then we will return that particular index, and if it doesn't, and loop terminates, then we will return -1. And here one thing, that means if the condition is not true in each iteration that the left sum is equal to right sum, then we keep on adding that current value to the left sum. Okay, so initially in the first step, since when the loop starts, so first we will check this condition, left sum is equal to right sum. So here the left sum is equal to 0, and right sum, if you check, then we are using this formula. Right sum is equal to total sum minus left sum and minus a of I. So whatever left sum we have got, that we are subtracting, and the current index we are subtracting, because in the question it is clearly said that that particular index where we get this condition satisfied, that is not considered in either left sum or right sum. So here it is said that the sum of elements before it and sum of element after it should be equal. So here 5 for the index position 5, here the sum of element left of it and right of it, that is considered. And since we have taken that total sum of the array, that's why we are excluding out array of I. That means at the index position we are getting this satisfied. So if we are excluding that, and if we are excluding the left sum, then we will be left with the sum of elements to the right of it. Okay, so left sum plus a of I plus right sum is equal to total sum. So we have just shuffled this formula only to get the right sum. Okay, so in first step we will get left sum is equal to 0, right sum is equal to 12. When we move, since this is not equal, then we will add left sum to the we will add 1 to the left sum. So when the second iteration starts, so again before adding it again, we will first check whether left sum is equal to right sum. So here left sum after last update it became 1, so 1 was left sum and current value is 3, a of I is 3. Now we are checking the value of right sum, that is equal to 9, still it is not equal. Then we add this 3, whatever we have got, 3 to the value of left sum. So the left sum value will become 1 plus 3, that will be 4. So in next iteration, when I will be pointing to 5, that time we can see the value of left sum is 4, and when we compute the right sum using this formula, we get the value of right sum is also 4. That's why here this condition is satisfied. So we are just returning from this condition only. We will return I plus 1 since the array is 1 based index. So instead of returning I, we return I plus 1. And we will not do any further execution because we have to find the first index. Your task is to find the first index of in the array where this condition satisfies. Okay, so I hope this example is clearly understood. So now let's try coding for it. I have already prepared the solution. I'll just paste it here. I have given very detailed comments against each line so that it becomes very easy to understand. So yeah, but then also we'll go through this line, this solution one by one. Just let me make it left align and yeah. So entire solution is visible on the screen. Okay, so here what we are doing, if you look at this function, then function will initialize the first two integer variables, that is total sum and left sum, and this will be 0. Then we are running a loop through the array A and adds each element to the total sum variable. This computes the total sum of all the elements in the array. The function then loops through the entire array again and check if the sum of element on the left side is equal, the sum of element on the left side of the current index is equal to the sum of element on the right side of the current index. This we are doing by checking left sum is equal to total sum minus left sum minus a of I, where a of I is the current element and I is the current index. Okay, if such an index is found, then we return I plus 1, which is the index with 1 based indexing, and if this condition is not correct, then we keep on adding the value of a of I to the left sum. That means whatever the current value we have got for that index, that we will be adding for the we will be adding to the left sum, so that it becomes helpful for the next comparison. But when this condition will be satisfied, then from that point we return I plus 1. If no such index is found, then we simply return minus 1. That's it. Only this only 1 2 3 4 5 6 7 lines of coding here. That's it. So I have added comments against each line, so it will become very easy to understand what each step does. Okay, so let's try compiling this code. So here we can see we have got correct output. That means it has returned the position of 5 according to 1 base indexing. So here it is 3 only. So this is correct. So let's try submitting the solution. So even the entire solution looks fine. All the test cases has been covered. Talking about the time complexity of this function, so here it will be in the order of big O of n, where n is the length of the input array. This is because the function loops through the array twice, each taking big O of n time. Okay, So in the first loop, what we do, we compute the total sum of all the elements in the array, which takes big of n time. In the second loop, we first check if the sum of the element on the left side is equal to sum of element on the right side of the current index. This also takes big of n time, because the function loops through the entire array again. Since the time complexity is of this one is big of n, so now it should be able to handle the large inputs also without causing any performance issue. Okay, so though we are iterating it twice, but wherever this condition is satisfied, so we are returning from that particular point only. So even for a second loop, it will not run up to n time in what to say, in best case. In worst case, yeah, if no such element is present, then it will go through both the entire loop and it will return -1. But if some element is found, then it will not run up to n. Okay, so this was the Java solution of it. So now let's go ahead and code for C++ solution of it. Even I have made that ready here as well. So here entire thing is same, the same logic is there. Even here we didn't have anything that was causing a separate for syntax issue for Java and C++. So even the same thing is working here. So this in the C++ coding. So let's try compiling this code. Everything same, completely same logic, same step, everything. So here also we have got correct output. Submitting this solution in C++. So here also it has covered all the test cases in C++ language as well. Okay, so using both the languages, so this problem has been solved successfully. So I'll provide the link for this question in the description box, and along with that the link for the codes here, that means codes in C++ and Java language. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.